Thank you very much for that introduction, Gretchen. I really could not have said that any better myself. Yeah. So what Dr. Mahan said before is he had fed soybean meals for many, many years. So what I'm going to tell you here today is probably not any news to you, but I will spend my 30 minutes anyway. And if nothing else, I hope I can lead up to the next speaker who is talking about something really new stuff about soybean meals, Dr. Elga. So what I'll try to do here is just talk a little bit about some things that we have noticed on soybean meal. But first, I want to acknowledge my good-looking co-author on the paper, Kelly Sotak. She is a PhD student in my group, and she will graduate next spring or next summer, and she has actually written the paper that you have in there. So when you see something that's called Sotak and Stein, it means Kelly, she did all the writing, and I did the proofreading, and that's how we work together very well. So Kelly has really written the paper you have in the proceedings, and also done some of the work that I'm going to present here today. What I'll try to talk about over the next 30 minutes is a few things that you may or may not be aware of, and I'll leave you with a few home. What are you doing, Scott? I'll try to leave you with a few take-home messages. First, I'll try to convince you that U.S. soybean meal really is of high quality. And this may or may not be a given, but it really is. And in particular, if you start traveling around the world and you look at what is available in some other parts of the world, you start appreciating what we actually have in the U.S. And I'll make a few points on that. U.S. soybean meal, I believe, also contains more energy than we currently have in our book values. And I'll try and show you some data why I believe that. So I think that we actually feed more energy from soybean meal than we think we do. I'll also show a few data on the standardized ileal digestibility of amino acids, and that indicates that the digestibility is marginally changing over time. And in fact, it's going down a little bit over time, if our data are correct. And then finally, I'll talk a little bit about fermented and enzyme-treated soybean meal, and I'll try to make a point that you may be able to use some of those sources of soybean meal in diets for weaning pigs. So that's kind of what I hope I can leave you with when at the end of my talk here. Okay, first, a little bit about the composition of soybean meal. You all know we have soybeans here in the orange bars. We have soybean meal, dehulled soybean meal in the blue bar. Obviously, high protein ingredient, soybeans, 35 to 37% crude protein. When we take the fat out and dehull it, we get up to 47, 48%, at least in this part of the country. So fat goes down in the soybean meal compared to the soybeans. Then we have carbohydrates, and in many cases we don't talk too much about the carbohydrates in soybean meal. But as you can tell, there's actually quite a few carbohydrates. And I'll spend a little bit of time today talking about, in particular, the soluble carbohydrates here. You can see we are in soybean meal close to 20%, 18-20% soluble carbohydrates in soybean meal. I'll talk a little bit about those also. And then we have the insolubles, or the NDF here, and that's relatively low. And just to give you a comparison, we have here soybean meal in red bars, DDGS in the yellow, canola meal in blue, and sunflower meal in orange bars here. And you'll see no matter how you express this insoluble fiber, we have much less fiber in soybean meal than we do in our other protein ingredients. And that's just a fact that we have, it's easy to dehull the soybean meals, so that's one reason why we get relatively low levels of fiber. Another reason is that the soybeans, the seeds themselves, are relatively large, and since most of the insoluble fibers are in the hull fraction, we get a lower proportion of that hulls compared to some of the other ingredients we have. So when we feed soybean meal, low fiber gets into the diet. Now, talk a little bit about energy. We do a large number of metabolism studies in our group, and we have determined the D and ME in soybean meal in quite a few experiments. And here's an average of 12 experiments, different experiments that we have conducted. And you'll see we have DE here are 3,858 kilocalories per kilogram, ME 3,535 kilocalories, and the ME to DE ratio of 92%. Compare that to NRC, you see NRC values, they are a little bit lower. 36.19 for DE, 32.94 for ME, and again, ME to DE about 91% here. The difference, more than 200 kilocalories, close to 250 kilocalories that we have found in those 12 experiments. We have found that that they contain more energy. Okay, so we looked at this and said, okay, maybe this is just because every time we do an experiment, we just go to the closest crushing plant we have, which is close to Urbana. So this is all just because of this. We have high quality soybean meal in Illinois. And so this is diluted by all the low quality soybean meal from Indiana and Ohio and other states. So, so we said maybe that's the point. So who do you think is interested in this? The Illinois Soybean Association, of course. So I used this data and went to the Illinois Soybean Association and said, let's really do a study to demonstrate how much better the Illinois soybean meal is compared to everything else. So we did that study. Kelly Sotak did that study. We collected 22 sources of soybean meal from all over the US, basically. And I have to say, we collected them from the crushing plants, of course. So if a crushing plant is located in Indiana, we don't know for sure that the soybeans were grown in Indiana, but they were crushed in Indiana or in Ohio or in Minnesota, where we got them from. And then we divided into 4 zones. The northern US, here was South Dakota, Minnesota, and Michigan. We had zone 2, was the eastern US. That was Ohio, Indiana, and Georgia. We had zone 3 was the western US, Nebraska, Missouri, and Iowa. And then zone 4 was Illinois. Okay, so we have 22 sources from these 4 zones. I'll just show a few numbers here. Crude protein, not surprisingly, you have less crude protein in zone 1, which was the northern US, Minnesota, and Michigan, and zone 2, much more crude protein. That was the east, Ohio, Indiana, Georgia. Zone 3, the west, was Missouri, Iowa, and Nebraska. We have less crude protein there, also similar to the north. And then zone 4 was Illinois, close to the eastern zone. Average, exactly what you would expect, 47.4%, right? So that was a crude protein, and I think there's nothing new here. We've always known that when we go north, we get less crude protein in our soybeans, and we get less crude protein also in the soybean meal. It's just not possible to get the 48% up there in the north. Looking at ME, we have again zone 1 in the red bar, zone 2 yellow, zone 3 in blue, zone 4 in green, and then the average in purple here. Okay, see, the zone 1 actually was pretty good compared to zone 2, very high, but zone 3 falls a little bit below here compared to zone 2, and Illinois was intermediate between these two here. So we had significantly more energy actually in zone 1 and zone 2 compared with zone 3, and Illinois was kind of right in the middle. Okay, so the average 4,044. So we go back to look at that and say, I showed you this before. This is what we had from Illinois over 12 experiments. This is NRC values. Now we come in with these 22 sources from all over the US, and you'll see we are very close on DE values compared to what we had in Illinois, which also fits well with what we showed before, that the Illinois value was close to the average. So really the conclusion here is not so much that Illinois soybean meal is better than everything else, because Illinois is actually very close to the average. The conclusion is that the average values we have here seem to be above NRC values, right? And so we've seen this. There's 12 experiments here with 12 different sources of soybean meal. We have 22 sources of soybean meal here, so it's a pretty big data set. So we are pretty confident in these values. Conclusion again is there's actually more energy in soybean meal than what we have in our book values. Okay. Talking a little bit about protein, obviously we use soybean meal to add amino acids to the diets, and I just have a few slides on that here. First, if you take soybean meal here, 47.5% crude protein approximately, compare that to corn gluten meal, 62, DDGS 27.5. If you look at the amino acids, you see a very different picture. More amino acids here in soybean meal compared to the corn proteins. And I specifically picked lysine and tryptophan because all corn proteins are low in those two amino acids. And if you express them as a percentage of crude protein, we have a lot more lysine and tryptophan compared with what we have in corn gluten meal compared to DDGS. So clearly a high quality protein when we express the amino acids as percentage of crude protein, which is what indicates the quality of a protein. Nothing new here. If you look at the digestibility, standardized ileal digestibility of amino acids, and I compare here to canola meal in DDGS, soybean meal in light blue, canola meal in dark blue, and DDGS in orange. And you'll see for all the amino acids, we have a greater digestibility of the amino acids in soybean meal compared to other protein sources. So not only do we have a better quality of the protein in terms of concentration of amino acids in soybean meal, we also have a greater digestibility. So that's good news. Now, one other thing you may not think about much about is the variability we have among different batches of the same ingredient. That's important when you formulate diets, right? So what I did here was I took the standard deviations around those numbers for digestibility. And I just compared the same three ingredients again, canola meal and DDGS and soybean meal in light blue here. And you'll see for lysine, we have a much lower standard deviation around that SID value I showed you before than we do for canola meal and for DDGS, right? Methionine, there's not much difference among the three ingredients. Threonine, we have the least again for soybean meal, tryptophan the least again for soybean meal. So now I've told you three positive things about the protein in soybean meal. One is we have more amino acids in the protein than we have in other protein sources. We have a greater digestibility of these amino acids in soybean meal, and we have less variability in the values for digestibility in soybean meal than we have in other ingredients, which makes it an easier ingredient, I guess, to include in mixed diets because we pretty much know what we get, right? So those are all positive things. Now, one thing, if any of you work with the soybean industry, you'll notice that over time, the concentration of crude protein in soybeans is reduced over time. It goes down slightly. It's not a huge reduction, but it is a significant linear reduction. If you go back 20, 30 years and until now, concentration of crude protein goes down. And I've been to many, many, many meetings where people have discussed why that is, and I always give them one answer. It says, as long as you don't pay producers based on the crude protein, that trend is going to continue to go down. That's the only thing there is to it. And I always tell them about the swine industry. When the swine industry figured out to pay people based on lean pigs instead of live weight, the lean percentage went up. And it's going to be the same thing with soybeans. As long as the industry cannot figure out to pay them based on the crude protein, that trend is going to continue. So what we did here was we looked at what happened to soybean meal. If we know the crude protein and the amino acids in soybeans goes down, what happens to crude protein? And this is some work done with one of my former postdocs. And she finished that, and we took our database, and we have data back to 98. And these are data not only from Illinois, but all the data we have been able to gather from the literature and put into the database. And we divided from 98 to 2006 and 2007 to 2014. For lysine, there is the p-value is actually 0.06, so it's not quite significant, but a tendency for a reduction here. There's a numerical reduction for methionine and threonine, and all other amino acids. There is a numerical reduction, but not significant over time, and this is a relatively short period of time. So amino acids seems to be going down a little bit in soybean meal over time. If you look at digestibility, and here it becomes a little bit more tricky because we obviously only can collect the data that are reported in the literature. So there could be other reasons why they change over time. There could be different techniques or different labs having different procedures and stuff. But if you look at just what has been reported in the literature, and there's about 40 or 45, I believe, numbers in each group here, from 1999 to 2006 and 2007 to 2014 in the blue bars. You'll see for all amino acids, there's a significant reduction in digestibility, okay, over time, right? This is not a huge or long period of time. As I said, there could be other reasons. There could be some specific reasons why that's the case, but this is just what we have been able to pull out of our database and seen, and that we have this reduction in digestibility. I don't know what to make about it. I don't think the soybean industry is overly concerned about this, but as swine nutritionists, we probably should be aware of this, right? That's just one observation we've gotten. One thing about soybeans, soybean meal, soybean products, you all know about is we have trypsin inhibitors in soybeans. So we have to heat those soybeans because trypsin inhibitors reduce the digestibility of all amino acids, and that is a major problem if we feed raw soybeans. So we usually don't feed raw soybeans. We have to have some kind of heat treatment. Okay, here's an experiment we conducted. We had raw soybeans, the light blue bars, heated soybeans, the dark blue bars. So this is the same batch of soybeans. We just didn't heat them, and here we heated them. And then we had regular soybean meal. And you can see the digestibility of the raw soybeans is very low for all amino acids. And when we heat those amino acids, we get them up exactly to where soybean meal is. There's no significant difference anymore. This is not new. That's why we have to heat soybeans. So question always is, particularly when you go abroad, is how do we know that the soybean meal has been properly heat treated? How do we know it's enough? And the most common way to assess that is to use a urease index, and that should be between 0.05 and 0.20. If that's the case, then you have proper heat treatment. If you go to the added expense and trouble, to analyze specifically for the trypsin inhibitors, you should get a value that's less than 4 milligrams per kilogram. But that's probably only done in research studies where we analyze these. Usually the urease index is used. Now the good news here is that if you buy soybean meal from a US crusher, you will not find under-processed soybean meal. You really will not find that. If you go abroad, it's a different story, but you have to really look hard and long to find some soybean meal from the US that's greater than 0.20. We really don't have under-processed soybean meal in the US. So that's good news. Heating is not necessary, however, overheating is also a problem, right? We have had several PhD students in our group working specifically to try to characterize aspects of overheating in many different feed ingredients. Show some values here for soybean meal. This is from one of my current PhD students. He did this before she actually became a graduate student, but she was an undergraduate student. But we had a control diet here. Soybean meal here we divided into 4 different batches. So one batch we did not heat at all. One batch we autoclaved at 125 degrees for 15 minutes. Another batch we autoclaved at 125 degrees for 30 minutes. And then the last batch we oven dried also at 30 minutes for 125 degrees Celsius. And you can tell here that the color changes. We measured the color changes. L star goes down for the autoclaved, but did not change for the oven dried. A star went up. That's the redness or the brownness of the sample. As you can tell, it went up here for these autoclaved samples and didn't change for the oven dried. So here you'll see there's a difference in the type of heat we use and also in the time we use that heat. So there are many factors involved in these reactions. Just to show a summary of this, if you look at the crude protein in these 4 sources, there's really no difference in the crude protein. Right? Because the nitrogen does not change, and nitrogen does not disappear. It may become in a different form, but the nitrogen is still there, so calculated crude protein is still the same. However, digestibility of amino acids, 93%, this is for lysine, sorry, 93% for lysine, 89, 84, so a linear reduction in the digestibility as we heated the soybean meal, right? And in some other experiments, we have been more aggressive and heated for a longer period of time. We can make the digestibility go down to 30 or 40% if we really heat them. And again, the oven dried was not significantly different from the control. Looking at total lysine, classical, it goes down when we heat treat, so we have less total lysine. When we autoclave here for 15 minutes or for 30 minutes, no change in the oven dried. And this is what always happens when you heat damage a feed ingredient. You see a reduction in lysine digestibility and a reduction in the concentration of lysine. Those two things always go together. They always go together. So both digestibility and concentration goes down. Now, if lysine concentration goes down, but crude protein is the same, then you will change the ratio of lysine to crude protein, right? And if you calculate that here, you will see that ratio here is 6.29, goes down to 5.75, and 5.57 in this case, where we had autoclave for 30 minutes and no change in the oven dried. This is one way you can estimate if a feed ingredient is heat damaged. Simply calculate this ratio, lysine to crude protein ratio. For each feed ingredient, there's a different optimum ratio, but for soybean meal, if you have this number greater than 6.0, you don't have heat damage. If it's less than 6.0, you have heat damage. That's a rule of thumb you can use. So that would be, and this is a lot easier to calculate than it is to do reactive lysine or other more elaborate procedures that are also available. But if you have NIR in the feed mill, you can get both the crude protein and the lysine, and you can quickly calculate this ratio, and you know if you have a heat damaged product. Okay. Good news again is the US crushers, they do a very good job. They don't under-process, but they really don't over-process either. So if you buy US soybean meal from a crusher here, you very, very seldom will find overheated products. And we're talking dehulled soybean meal. If you have some of the other further processed soybean products, you have to be more careful, and I'll show some numbers on that a little bit later here. Okay? But remember the 6.0 as your standard. I showed you before the SID of amino acids in soybean meal, canola meal, and DDGS. I showed this slide before. One thing I didn't point out, and you can also look at, is that the digestibility, the standardized ileal digestibility of threonine should always be the least of all the indispensable amino acids, because you have more endogenous losses of threonine than any other indispensable amino acid. So threonine should always be the least. If you look at a protein where you see lysine has a lower SID value than threonine, then you almost for certain know that protein is heat damaged, right? And you'll see here, if you look at them, soybean meal is greater than threonine. When you look at lysine here, canola meal is greater than threonine, but when you get to DDGS, in this case, then DDGS is less than it is in threonine. Lysine SID is less than in threonine. That indicates that this lysine was heat damaged, right? And these numbers are from NRC, so I just took the SID values from NRC, and what that tells you is that on average of all the DDGS sources that went into the NRC database, on average those DDGS sources were heat damaged, because otherwise you would never get a value here that's less than threonine. Okay, so that's another way you can have an indication of if there's heat damage in a feed ingredient. Okay. Now we have talked about, we have these carbohydrates in soybean meal. We feed a lot of soybean meal to our pigs, but the one area where we have to be careful with soybean meal is obviously in the weaning pigs, early pig diets. Historically, we have not been able to just feed soybean meal there as the only amino acid source. Once the pigs are 40, 50 pounds or greater, we can use soybean meal as the only source. But young pigs, of course, we have historically always used animal protein sources there. However, there are a couple, and there are good reasons for that, and we'll talk about those reasons. And there are some new sources of soybean meal on the market now that you may be able to use instead of the animal protein sources. So I'll have a few slides on those. First, I want to come back to the carbohydrates. I said we have soluble carbohydrates in soybean meal. And I told you before, one of the first slides, we have close to 20%. If you divide those 20%, then you see we have about 4% free sugars. We have sucrose, and that is quite variable in soybean meal. I put it 8% as an average here. It can be more than that and can also be less than that. And then we have what we call the oligosaccharides or galacto-oligosaccharides, which are mainly stachyose and raffinose and a little bit of verbascose. Okay? So one of the reasons we cannot feed a lot of soybean meal to our young pigs is because of these oligosaccharides, because young pigs don't tolerate oligosaccharides very well. They cannot digest them, they don't have enzymes to digest them, and so they have to ferment them, but they don't do a good job of fermenting them. Sucrose, of course, does not cause any problems. It's very rapidly digested and absorbed. The free sugars don't cause any problems either. It's the oligosaccharides. If you look at those oligosaccharides, 6.3% here, raffinose 1.2, stachyose 4.9, and verbascose 0.2, and these are some average values. There is some variability in that also among different sources. Now, what does this do to pigs? There's an experiment here where they fed stachyose. This is synthetic stachyose. They added to a stachyose-free diet, and these pigs were weaned, and then they were fed for 21 days post-weaning. They had the control here in light blue bars, 1% stachyose in dark blue, and 2% stachyose in the orange bars here. And you'll see that average daily gain linearly was reduced as they added more stachyose to the diets, right? And no significant difference in average daily feed intake. Gain to feed was not significantly different, although there was a numerical reduction. But when they looked at diarrhea, there was a linear increase in diarrhea as they added more stachyose to these diets. So this is a good reason why we shouldn't add a lot of soybean meal to our weaning pig diets, right? We don't want them to have a diarrhea. We don't want them to reduce average daily gain. So that's one problem we have with soybean meal for young pigs. Another problem is what we call antigenic proteins. And if you look at the total group protein here in a light blue bar, in this case, this was while I was in South Dakota, low protein dehulled soybean meal. See, it's barely 45% group protein. We divided that into, we also measured glycinin, which is one type of protein, and beta-conglycinin, another type of group protein, and you'll see those two proteins combined actually is almost all the group protein we have in soybean meal, or a large part of the group protein are these two proteins. Those two proteins are believed to be antigenic to young pigs. Okay, in particular, the beta-conglycinin. That's the most antigenic protein we have. So that's another reason we cannot feed a lot of soybean meal to our young pigs, because of these antigenic proteins. So what we did here was said, what if we remove both the oligosaccharides and the antigens? There are products out there that don't contain these sources. We can remove them via fermentation or via enzymatic hydrolysis. So we looked at that, and here we have conventional soybean meal, we have enzyme-treated soybean meal, and we have fermented soybean meal. Okay, sucrose in the blue bar, stachyose in light blue bar, stachyose in dark blue, and raffinose in the orange bar. And I put in sucrose here because that changes also. That's not a problem for the pigs, the sucrose. These two are the problem for the pigs. This is a normal. In this case, you can see we are close to 9% sucrose, close to 6% stachyose, so high stachyose concentration. If we compare that to enzyme-treated soybean meal, you'll see there's no sucrose left, absolutely gone. There's a little bit of stachyose here, but very little, and there's very, very little raffinose. Okay. When we looked at fermented soybean meal, in this case, there's nothing left. There's no soluble carbohydrates left because they are fermented, right? And I should say we call this enzyme-treated soybean meal. It's actually also fermented, but it's fermented in the presence of enzymes, and therefore we call it enzyme-treated soybean meal. But these processes really gets rid of the soluble carbohydrates. So if the stachylose and raffinose, if that's a problem for the young pigs, we'll say, well, we have some sources here of soybean meal that does not contain those oligosaccharides, right? If you look at the crude protein, this is in fermented soybean meal. This is an experiment we conducted. In all these fermented soybean meals called A, B, C, and D, they came from Asia. You have many different fermented soybean meals in Asia. To my knowledge, we only produce one source in the US of fermented soybean meal, and we also produce the enzyme-treated soybean meal here. But if you look at the crude protein, it's greater than it is in conventional soybean meal. The reason, of course, is if you remove 16 to 18% soluble carbohydrates, everything else gets more concentrated, right? I would want to say one thing, and you see there's kind of a little bit of variability here. Sometimes you can find fermented soybean meal or enhanced soybean meal where they do get the protein up to some degree. But if you then look at the dry matter, you'll see you have dry matter at 96 or 95%. So one of the reasons they get protein up is they dried the water out, right? So that does not, just because you have high crude protein does not necessarily mean that they have removed oligosaccharides, right? So you have to be careful with that. Glycine, beta-conglycinine, we did the same study as showed before. Conventional soybean meals, enzyme-treated soybean meal, and fermented soybean meal here. Light blue bar is glycinine, dark blue is beta-conglycinine. Remember, beta-conglycinine is the most antigenic protein we have. This is a conventional soybean meal. The enzyme-treated soybean meal, you'll see, it's very much reduced in terms of both glycinine and beta-conglycinine, right? They have really reduced it, and I believe it's because of that enzyme treatment that they break down those proteins, and therefore you don't have the antigenic proteins there anymore. And you'll see in this case, the fermented soybean meal, there's no change in the glycine, but the beta-conglycinine was reduced by more than 50% in this case. But the enzyme-treated soybean meal really took care of these antigenic proteins. Amino acid concentrations does not change, so it doesn't remove the amino acids, so it must just digest those proteins, right? So that's what we see here. So because we have taken out the oligosaccharides and because we have reduced greatly the antigens, that means we actually have two sources of soybean meal here that can be used in diets for weaning pigs. And obviously with all the discussion about use of plasma proteins and animal proteins right now in pig diets, this has become a much more important topic over the last few months here. Standardized ileal digestibility, we have always been concerned if you ferment, do you damage the digestibility? This is fermented soybean meal. These are data from another one of my PhD students. We have conventional soybean meal in orange, fermented soybean meal in blue, and fish meal, in this case, in red. And you'll see that the fermented soybean meal falls right between conventional soybean meal and fish meal, in this case for lysine, methionine, it's the greatest one, threonine, the greatest one, and we don't see a reduction in digestibility of amino acids in these products in general. We see about the same. Phosphorus digestibility, conventional soybean meal orange, fermented soybean meal in blue. We see an increased digestibility of phosphorus in fermented soybean meal compared to conventional soybean meal if there's no phytase in the diet. And the reason is the fermentation will break some of those phytate bonds, so we see an increased digestibility. We've seen the same thing for enzyme-treated soybean meal. It's not only the fermented here. But if we add phytase to the diet, both sources, both the conventional and the fermented, are very, very well digested in terms of phosphorus, right? So you get, but if you don't use phytase, you will get higher digestibility. Energy, fermented soybean meal, conventional soybean meal, corn, and fish meal. In this case, we had a little bit greater digestibility, a little bit greater ME in soybean meal compared with corn, which is not unusual, but also compared to the fermented soybean meal. We believe that's because we get rid of those soluble carbohydrates, in particular the sucrose, which is very readily available. So when you get rid of that, you reduce, in this case, the ME value a little bit, but not greatly, but a little bit. But it's interesting to see that the fermented soybean meal is still greater in ME compared with the fish meal here, right? And fish meal, I think we talked about that 2 years ago. I gave a talk. Fish meal ME goes down over time because we see more and more ash in our fish meal. So the quality of fish meal has gone down as the price has gone up. Enzyme-treated soybean meal, ME, no difference between the enzyme-treated soybean meal and the conventional soybean meal in this case, and again, a little bit greater than in corn. So energy is not compromised really, and we get more energy from these sources of soybean meal compared to fish meal and close to what we get from conventional soybean meal. However, these sources of soybean meal, they are not only fermented, then they have to dry them again, so you have another risk of heat damage. And I showed you before numbers for 4 different sources of fermented soybean meal, and we have conventional soybean meal here. And you will see here we have lysine concentration bounces up and down a little bit. Crude protein, I showed you these numbers before. SID of lysine, 78, 82 for these 2 sources, 88 and 89 for these 2 sources here, and then soybean meal in this case was 87. So you'll see that you have very good digestibility in these 2, but not so good here. We looked at the lysine to crude protein. Remember I told you if it's less than 6.0, then it's heat damaged. If it's better than 6.0, it's not. And here you'll see less than 6.0, they have low digestibility. Above 6.0, high digestibility, right? So it fits in. So what they have done here is clearly they have fermented the soybean meal, and then they have dried it, and they have overheated it, and that's why they get the lower digestibility, right? And I've discussed this with many companies who produce this, and they put all their money into the engineers to construct the fermentation unit and into the scientists to get the fermentation right and stuff. And then at the end, when everything is ready, they buy the cheapest dryer they can get, and then they destroy the whole thing, right? So the drying process is very important here. Now, one other thing I want to show here is we measured the TIUs here. There's no TIUs or trypsin inhibitors here. That is not necessarily a good thing, because that means you have dried so much you've gotten rid of all of them. I said before, if you're below 4, you are fine. And these 2, you can see they have not over-dried them. We have a little bit of trypsin inhibitors. That's fine. It's not a problem at all. But the soybean meal in this case, 7.8. Right? I told you before, you cannot find under-processed soybean meal in the US, and this is actually crossed in Asia, and we import, all these products are from Asia, so we import everything from Asia, and you can see in this case, they have under-processed that soybean meal a little bit. You would not find that in the US, I don't think. We have never seen that. So again, US soybean meal are very high quality, but you can destroy it. Few conclusions. I've tried to make the point that soybean meal is a rich source of very digestible amino acids, not much variability. US soybean meal is of very high quality, but the SID of amino acids appears to have been reduced over the last 8 years, as I showed you before. I've shown you data that indicates that we have more energy in soybean meal than previously reported, and we are more and more convinced that is the case. And finally, showed you that fermented or enzyme-treated soybean meal may be used in diets for weaning pigs, because we get rid of the oligosaccharides and we get rid of the antigens, and therefore we can use those sources. So with that, I want to make one last point here. Dr. Mosher said that we should be on Facebook and everything, and we have a web page, Dr. Mosher, and you'll see here we are on Facebook, we are on Twitter, we are on YouTube. So you can actually, you can go in there and you can like us. And I haven't checked our hits, but I would estimate we are probably very close to that 14 million number there that you showed. We put all our stuff on the website, so you can go in and look at our research, all our publications. We have newsletter every month coming out. We have podcasts. If you don't want to read, you can listen. And then we also have a feed ingredient database, a pretty extensive feed ingredient database you can go into here. Just want to show one thing. This is soybean meal I went into. We have the composition here. We have both energy for pigs and for poultry. We have amino acids. We have digestibility of amino acids for pigs, digestibility for poultry here. We have a total of more than 220 feed ingredients in the database here. So, and you can actually, we have it divided, you can see the region here says world. You can go in and you can select Europe or Asia, or you can select Illinois if you only want Illinois, or the US or South America, wherever you are located. So there's a lot of opportunities here to select these feed ingredients. So if you want to take advantage of that, it is available on our website. So with that, Gretchen, I want to acknowledge all my students and postdocs, technicians who have helped me with the data I've shown here today. And again, if you want to go to our website, please feel free to do that. With that, Gretchen?
Thank you very much.